Greetings, geographers. Welcome to a quick short video on urban heat island, of which I felt we should do in this series of exam revision. It's a figure 1.2 and a set of 5 questions. Let's dive right in. The air pressure 1.2.1, the air pressure will generally be higher or lower in urban areas than in rural areas. Well, in urban areas, it is said that there are higher temperatures than in the rural areas, right? And higher temperatures equals to high evaporation rate, meaning is equals to a low pressure, right? And I'm only writing this as like an equation because I love maths, okay? But lower temperatures will equals to more subsidence of air, right? As illustrated here, if I were to complete this diagram, this would actually be more subsidence of air, right? Lower temperature equals to more subsidence of air is equals to higher temperatures, okay? It's equals to high pressure, high pressure, low pressure, high temperatures. Okay, so the air pressure will generally be high or low in urban areas, while air pressure will be lower in urban areas. The correct answer here is lower. It's lower, okay? Let's move on. 1.2.2. The temperature difference between the city center and the rural area is approximately, well, this is just taken directly from the diagram. I think it's quite visible that it's about 39, 38 right here. And here it's just below 34. Okay, from 34 to 39 is like 5, right? 5 degrees. Okay, so I hope we are all comfortable with saying the correct answer here would be 5 degrees. 1.2.2 is 5 degrees Celsius. Okay, the sketch below typically shows day or night time conditions. Okay, so an urban heat island, excuse me, generally in nighttime, it'll have a more compressed shape, right? A more compressed shape due to the subsidence of air. Or some textbook would say lower vertical dimension, meaning that it is more compressed, right? And then in daytime it'll form like, some textbooks say mushroom shape or something, mushroom shape, but essentially what that means is that it has a higher vertical dimension, right? So if we were to look at this specific diagram here, we see this sort of mushroom shape, okay, and we see that it has a bit higher vertical dimension, right? You see that here's the city, the tallest buildings in the city, and you can see like how far away from those tallest building that the pollution, sorry, that this sketch happens to be above those buildings, right? Meaning that this would be daytime, right? Because we said this was night and this was day. So this would typically be daytime conditions. So the answer for 1.2.3 is day. Okay, cool. And to add on that, urban heat island usually occurs during the day, right? 1.2.4, cool or warm air moves in from the rural areas. Key phrase here, from the rural areas, to replace the rising air. Okay, you can see a lot of trees here, and we know that rural areas are said to have lower temperatures, right? So there is no way that higher temperatures can move in from here to the urban areas. That means that cool air moves in from the rural areas to replace the rising air. The answer for 1.2.4 is cool, right? 1.2.5, the great vertical dimension, once again this appears, great vertical dimension of the heat island shape is influenced by the strong subsiding air will result in a lower vertical dimension, right? Or a dome shape, if I may say, right? Then rising air, as you can see here, rising air results in a greater or higher vertical dimension, right? Meaning that the correct answer here would be rising. So that was quite a quick video. It was a question that I felt was necessary to do. I hope that you found it quite useful. Do like and subscribe and stay tuned for more. Thank you.